Hello, friends. Welcome back to Commute Talk. Thought I would talk a little bit about WebKit again today, and about this browser performance benchmark that we made at Apple in 2014, I think it was. Um, because browser performance benchmarks, they used to be extremely JavaScript centric. Like when you were talking about browser performance 10 years ago, it was all about JavaScript performance. And other than that, there were some like correctness benchmarks, like ACID 2, ACID 3, those types of things. And then there was one major non, not non-JavaScript I was gonna say, but like it was still making heavy use of JavaScript. It was Dromeo. It was supposed to be a DOM benchmark. But of course, any benchmark implemented in a browser is going to be using JavaScript. But basically, the landscape of browser benchmarking in 2014, 2013, whatever, before we made the Speedometer benchmark, it was very JavaScript centric. And the three main benchmarks were SunSpider from Apple, and Kraken from Mozilla, and Octane from Google. And it was like a sort of this typical thing where each browser vendor has their own benchmark that they control and they target, and they try to include the stuff that they think is important, and then they of course they like optimize heavily for the benchmark. But and we certainly did optimize heavily for the SunSpider benchmark, but we also had like continuous performance bots running tests on Kraken and Octane, and we were targeting those benchmarks as well in WebKit. And actually, I remember that SunSpider got to a point where it was just so optimized that there was not much you could do with it anymore. Like it got down to like I don't know, it took like 100 milliseconds or something to run the whole thing. So, which was good, and we still wanted to keep it around for regression testing, but we needed something new. And we knew that we wanted not just something for JavaScript this time, but something that could test the whole browser. And we had seen Dromeo, and we knew about Dromeo, and I've talked about Dromeo before. And Dromeo was a set of micro benchmarks that would like call some DOM API repeatedly in the loop, and then just see how many loop iterations we can do in like a minute, basically. And there's some use for that type of thing, but it's not really a very good macro benchmark, obviously. So we wanted something macro. And what we came up with, and I really should give credit to Ryosuke Niba for this because it was his brainchild. What we did, or what he did, was he made a benchmark that takes this example application. So there's a thing called to-do MVC, which is it's a set of example applications in JavaScript, or in web applications, not just JavaScript. It's a set of example web applications that implement a little to-do app where you can make a to-do list for yourself and then check off items as you do them. It took that example suite made with all these different frameworks and then automated it so that we would create a to-do app. We would instantiate a to-do app in one framework and then interact with it a little bit, simulated interaction, and then get rid of it, and then load a to-do app made with another framework, interact with it, and so on. And it turned out that this was an absolutely fantastic way to test out all kinds of parts of the browser engine, because every JavaScript framework or every web framework, they do things in their own little ways, and they have all these different pathologies and idiosyncrasies. And by testing like we did before with Dromeo and like JavaScript micro benchmarks or even JavaScript macro benchmarks. Well, in testing that way, we never really got too close to the way that the web was actually like, which is of course what you would really want with a browser benchmark. You want a benchmark that simulates in a microcosm as well as possible what the actual web behaves like. And with this idea for Speedometer, we were able to condense pretty typical web page stuff into a very repeatable benchmark, and it was just really great when we got it working, because the numbers were stable, it was not flaky, and we were able to put it on a bot so that it would run all day long, and we could start working on it and try to improve it. Of course, the original name for Speedometer was not Speedometer. Speedometer was a name that they came up with in the Apple marketing department, because it was supposed to be speedometer, like speedometer, like DOM and document object model. It's very, very clever by the marketing team there. The original name for Speedometer was Do You Even Bench? Which I still think is a better name to this day. And I love the double meaning of it, right? That like, I mean, I'm gonna do the horrible thing of explaining the joke now, but because it's a reference to the age-old meme of "Do you even lift?" Which was funnier at the time than it is today, perhaps, but that's just how it goes with these things. But I love that "Do you even bench?" works in the original context of "Do you even lift?" because it could there refer to bench press, whereas in the new context it also works because do you even benchmark your browser, bro? Right? Oh god, I can't believe I explained the joke. Anyways, I love that. I love that name, and I was so sad when marketing made us change it. And I wish I could take credit for the name, but it was actually my chucklehead coworker Anders at the time who came up with it, and it was a great name. Wish we would have kept it. Do you even bench? Or DYEB, as we also called it. It's a good benchmark. It reminds me of I remember doing an optimization for Do You Even Bench, where I discovered that the way that the simulation worked, the way that we would interact with these pretend to-do applications was that we would instantiate the app, and then we would sort of traverse over all the UI elements in the web page, and for each button or text box or whatever, we would like type a little input and then click on the buttons, just to simulate user interaction. And it turned out that the pretending to click on the buttons, it was very, very slow, and not for any reasonable reason, but rather when we would simulate the click, then WebKit would do its best to make it look like it was a real click, and that included instantiating a mouse event, like a DOM mouse event. And a mouse event normally includes the coordinates where you're clicking, but also the coordinates, the mouse coordinates in the global context, so like the screen mouse coordinates. And in order to retrieve those, I mean, normally when you're doing like user click processing, user mouse event processing, then you have the global cursor precision because it's just passed along from the OS when you get your mouse event. But in this case, when you call like element.click in the web API, then we would synthesize a fake mouse event, and we would populate the screen cursor precision by sending out a request to the operating system to tell us where the cursor is. And this was actually a synchronous IPC request from the web renderer process to the Safari user interface application process, which then in turn had to go and ask the operating system, like, hey, where's the cursor? And this meant that for every iteration of the loop where we wanted to click on something, we had to block the web process and send a synchronous IPC call to the Safari UI process, and then wait for him to finish whatever he was doing, and then he would ask the operating system, hey, where's the cursor on the screen? And then finally get back to the web process, which could then continue running the test. And this was a huge slowdown because it turns out that serializing things that could be done in parallel is maybe not the best idea. I know, right? So, but this problem was actually in the engine for quite a while, even after we created the test, and I only discovered it by accident because it turns out that I was doing most of the performance work using the Apple Instruments profiler back then, and Instruments by default will only collect call stacks when the process is not blocked. So like whenever he's running and doing something, the Instruments will think like, oh, like this process is doing some busy work. We need to look at what that is and accumulate that stack. I don't know if you know how a profiler works, then you know what I mean. Like it was only collecting busy stacks basically, and then it turns out that there was a setting in Instruments that I just started playing around with because I thought it was interesting. It was called something like also profile blocked processes or blocked threads. And when I turned this on, then I could see that we were actually spending a ton of time in element.click. And if you would drill down, you could see like actually we are spending a lot of time in I think it was something like simulated mouse event create or something like that. I don't remember the name exactly, but there was no CPU time being spent, but it was just like wall time, and it was because we were blocked on the synchronous IPC call. So I just discovered that because I was messing around with Instruments and trying out this option, which maybe should have been a default on option, I don't know. Anyways, I was very happy to discover it because it was a huge win on the bot, like on the automated testing of the benchmark. Or, I mean, it was a huge win on the benchmark in general, actually. But I have to admit that it was not a huge win in real world. So, like, in the real world scenario that this test was supposed to simulate or approximate or whatever, of course, you're not using element.click. You're actually clicking with the mouse yourself or with your trackpad or whatever. So this wasn't this didn't really translate into any user benefit. But I was still happy about it because it was nice to see the number on the bot go down. And with a benchmark like this, it's very good to remove anything that's taking up time, even if it's only in the testing environment, because 10% less time spent in this fake mouse event stuff means that we can see 10% more of the other stuff, if you know what I mean. Like it will give more space for other things to show up, and we can see what becomes like the bottleneck now that we've removed the previous one. So I was happy about it, but it felt a bit like I mean, it was obviously like a benchmark hack, but it still had to be done. Good times. I don't know why I started talking about this. I was just reminiscing about Speedometer, I guess. Or do you even bench? It's a good benchmark, I think. And after we put it out, then other browsers started tracking it as well and optimizing for it. And I think the web is better off for Speedometer existing. Then, like a few years afterwards, there was we did an update to it where we updated it to use newer versions of the web frameworks and stuff like that. And that was good because web frameworks get a lot of heavy development, so you can't just like stick with your copy of jQuery or Angular or whatever, React, Ember that you made in 2014, like, because those frameworks are very different things now in 2019, right? So maybe it's time for another update. I don't know. If you're watching this, Jessica, maybe you should go update Speedometer. I hope you're doing well. And yeah, so I guess I ran out of steam here, so I'm gonna stop cackling. But that's just a little bit about Do You Even Bench. So thanks for hanging out with me on the commute, and I will see you next time.